Thank you very much, Manuel. Thanks very much. It is true. Good morning, everyone. Thanks for having me in Sydney. Always enjoy coming to visit you down here. One of my core roles is actually to help you out Australia-wide as well. So with functional programming. So yeah, I'm going to talk to you about aviation. This is mostly a fun talk for a number of reasons. One is it's an application of functional programming. So in order to get from no argument up to why I should put this stuff in my aeroplane, it's a really long talk, many years long. So I'm going to sort of just have some fun instead, but I'll show you some concepts along the way. So to them, functional programming is just some fuzzy idea that they've not really dabbled in. It's just they've heard like that'll be some amount of people. You know, you don't write Haskell at work next week. You're going to be writing Python or Java or something. So is that most people? Can I just see that again? Okay, I assume that. I'm going to take a quick excursion off to the side and I'm going to tell you what functional programming means. All right, it takes about 3 minutes, last I checked. So basically, if you have a program and you see something like, I'll just make that a bit bigger, array.update. Now this is just whatever programming language, you know, like this, and then you see array.update ix. And then there's the rest of the program. We'll call this program P1. Right, that's program P1 there, whatever. It indents like this new language I just invented. Okay. and what you do is you refactor this code and you say, I'm going to refactor out this code here and I'm going to name it something, right? So something, that's how my imagination, that's the limits of my imagination with variable names actually. You refactor it to that. And we ask the following question. Is P1 equal to P2? Are they the same program? Now, if you're doing an array update and it updates that array in place, these are different programs. Does everyone agree? Okay, this is the opposite of functional programming, dysfunctional programming. As opposed to, I guess Java strings, if I remember rightly, they're immutable, so it returns a new string. Okay, so if I did something like that, it doesn't update the string in place. It returns a new string. So these are the same program. Does everyone agree with that? Okay. So functional programming is a commitment to preserving that property of being able to replace expressions and values without changing the program. That's the definition. This has some consequences like, I don't know, maybe last week you wrote that somewhere. This breaks the rules. So we don't have those kinds of things when we're doing functional programming. So what do we have? And that's a question that I'm committed to answering. That's my job, actually. I work here at the QFPL, the Queensland Functional Programming Lab based in Brisbane for Data 61 under CSIRO. And Queensland government says, help Australia use functional programming. And I say, OK, that's it. So come and knock on my door and I will help. I'm not kidding. So this is a frequently asked question that I've been receiving lately, so I've just made a slide for it. Do you do functional programming courses? Yes, I think some of you in here have done that. How do I get notified? That's how. Do we do non-introductory? So I've done all the basics and I want to go and write a web app. It's a common thing I get asked. Yes, we're going to do that. And yes. No, I'm serious. I've been using Haskell for over a decade now, and we're hiring. Would you like to come and play? The end of my spiel there. Okay, so why aviation? It's a very simple answer. It's not complicated at all. My house is near this airport. This is Archfield Airport, just south of Brisbane. It's just to the west of Archfield Airport. And this is me on my way home from work on the Ipswich motorway. Or it's a depiction of it. And there's me there. I say, oh yeah. It's not really me, it's a depiction. I duck more than that. So I did that. It's very simple. And my wife said, that? If you've ever looked into what those Google results do. And I did that. And then I won the argument. So that's called compromise. As far as functional programmers are concerned. So, mostly a joke, but yeah, you know how that goes. Okay, so let's get into some aviation stuff. So just, if you're not familiar with aviation, these are just some basic things to know. There are 4 levels of license. I am almost ready to sit my test for PPL. That's where I am. When you take off from Sydney Airport to come visit me, you'll be flying with an ATPL, all right? So I'm not allowed to do that. I don't have that license. So there's an organisation or a regulation authority called CSIRO. You've probably heard of them. They set all the laws and enforce the laws and so on. In my experience, CSIRO has been quite helpful. They tend to take a educational position rather than a punitive position. If I accidentally do something wrong, they don't wrap me over the knuckles. They help me do better. That tends to be the case. I like that. I like that about aviation. And there's another organisation called Air Services that gives us weather reporting and traffic control and so on. And you've probably heard of this. You can't get a train to my house, or you'll be switching trains, or something strange will be happening. It's because the rail gauges don't line up. So we have these international organisations, and what their job is to do is to set international standards of which Australia is a signatory. So, you know, we're flying, let's say, Singapore, and there's 2 aeroplanes coming together. We don't have an argument about which way to turn. These guys have told us which way to turn, so that we don't hit each other. Simple as that. So in Australia, we have the CAA, and under that, the CASR. These are just 2 regulations. If you ever want to go and read about it, it's not that exciting, but we'll have a quick look at them. And there's orders. So if there's a need to update legislation, usually an order will be issued. And then there's also advisories. That's generally how aviation civilly works in Australia and many other countries as well. So I'm going to talk about pilot logbooks. The reason is we're all programmers. And I'm going to ask you to sympathise with this problem, all right? Because I think you're going to see the problem. So this is actually the legislation, but just to summarise, it says if you're a pilot of an aircraft, you must have a logbook. It must be up to date and so on. That's just a law under the Civil Aviation Safety Regulation. That's pretty much all that says. This is what they often look like. Well, unless you're an ATPL, then you've got stacks of them. Okay, so you know each row is a flight. Has columns. Some of those columns, to me, are type errors. That is to say, they can't both be filled out. So there are certain conditions under which filling out both of those columns is not a thing. All right, so I can't quite think of some off the top of my head. You weren't flying both a single engine and a multi-engine aircraft at the same time. Not happening. Well, actually, if you lose an engine in your multi, maybe you are, but anyway. I'd have to look the regs up on that one. Okay, so are electronic logbooks okay? Are they within the law? And the answer is yes. This basically says, yes, you can, but if CASA comes and knocks on your window, you need to be able to produce a paper copy. That's the law. So I carry an electronic logbook, and they knock on my door, and I send it to the printer. All airports have multiple printers. Aviation loves paper. Okay, so you will know then, as a programmer, that the first thing that's going to happen is that there's going to be a pilot logbook industry. You know that, right? You predicted it. So here's so-and-so. This is one day on an aviation forum snapshot. All right? So this guy's on a budget. What's everyone using? This guy made an Excel spreadsheet. I'm happy to put it on Dropbox for you. This guy likes a program called Log10. Never seen it myself, but apparently it's sexy. This guy, what does he want to do? He wants more features from the proprietary software. This person loves it. This person hates it. And this person hates it when he crosses, or he or she crosses the date line. Not cool. I'm not trying to scare you, by the way, but there are things like this in aviation. Crossed the date line, the date changed, the logbook software crashed. Lucky it was the logbook software, right? Not the avionics on board. Okay, so this, it's probably a bit difficult to see, but this basically says, what happened here? Oh, I want an internet backup. It syncs when you use Google Sheets, and this person says it's free right up until the moment you accidentally delete it and discover there's no backups. Whoops. You wouldn't want CASA knocking on your window that day. So I'm going to make a claim. Here's my claim. If you are a responsible pilot, you're using Haskell for your logbook. I'm going to do my best in the short amount of time we have to explain why. So I'm going to use, so things like lenses, prisms, and traversals are consequences of functional programming. So for those of you who are not introduced to functional programming yet, these are consequences. So once we sort of do the basics, I would then talk to you about those kinds of things. These are data structures. Same with a zipper. And I'll just write a function, compile my logbook out to paper format, write a little compiler. And we all know what revision control is. We just use that. No losing my logbook. And open source, because I'm a nice guy, right? So I do quite a lot of open source software. So I'm going to tell you what a lens is. I'm going to try my best to tell you what a lens is, and mostly a lens and a prism. All right, so are most people familiar with languages like Java or C# or JavaScript, something like that? Okay. Here's what I'm going to do. I'm going to tell you that all data types must be immutable. This is also known as functional programming. And you're going to complain to me straight away, because we're going to write our logbook. And I'm just going to step through this code here. This is Java. Java, as it were, in the 1960s, when it got lambdas. I'm only joking. It's the 1990s model. All right, so we have to write an immutable list. A real one? Okay, there is such a thing. I wrote it 15 years ago in Java. It does exist. And it has these functions. Is empty, cons is put an element on the front of the list, head is get the first element of the list, tail is get everything but the first element. This is all our entries that go into our logbook. So what I'm trying to demonstrate here is the problem if I said to you all data types were immutable. Right? So I think we all roughly agree that there are some advantages to doing this. So putting the functional programming argument aside, most people, I think, agree that there are advantages to doing this. Does that sound right? Anyone disagree? Be brave. Okay. So if I said to you, you would have this. You would have a logbook, and the logbook would have the person's name and details. This is called, in Australia, called an aviation reference number. An aviation reference number is a list of digits of 0 to 9. Okay. And then I said to you the following thing. Take the logbooks, aviators, aviation reference numbers, first digit, and if it is even, the first digit that is even, add 1. All right, now, if you were not doing immutable programming, immutable data types, that would be very easy. Does everyone agree with that? You go ... get all the fields and so on, and then you just go add 1, and you update it in place. Solved. So this is a common complaint I get. They say, hey, look, functional programming and immutable data types are a great idea, but when I want to do this, my code looks like this. Okay, so I checked last night, this compiles. So basically it says go down, get. So we have to do, when we go into a data type and we look at a thing that is definitely there, like a logbooks has a name, which definitely has an ARN, which has 0 or many digits. All right, so this is 1, 1, 1, 0 or many. We solve this problem, us functional programmers, using lenses for the 1 problem and traversals for the 0 or many problem. All right, so that's a lens tutorial in like 5 minutes. We can do it for days if you like. When you have a 0 or 1 problem, we use a prism. Okay, so has everyone heard of this data format called JSON? Yeah, I've heard of it. Some people send it to me by network sockets, and it's like, oh, what do I do with it? But if I said to you, go into the key ABC, and you'll find there an array, maybe, right? 0 or 1 arrays, and you'll find 0 or 1/4 elements of the array. And if it's there, then you'll find another key, DEF, which will have a Boolean, negate it. All right, if I gave you this problem, and it was an immutable JSON data type, you have this problem. It's like get, set, 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 right? Are most people sort of roughly familiar with this problem? Your code looks like a greater than sign, get, and then you reconstruct. And then you go, oh, screw functional programming, I'm just going to put a variable. Some of you have done it, that's all right. It's okay. I will forgive you. After I forgive you, I will show you how to actually solve this problem. All right, so we all agree And it's been around for a while. It's called functional programming, immutable data types. Okay, so I think I just did this out of order, but yeah, we're aware of some of those problems. If I just said to you, all data types are immutable. Your file input stream is an immutable data type. What now? All right, that means we need new tools to solve problems. So, there's that problem there. Find the first digit that is even, and if it exists, add 1 to it. All right, so I'm going to try and show you. This is the Haskell program that did it. So basically, that dot there is function composition. So I don't know if you might remember undergrad or something where you were doing discrete mathematics and you saw this circle symbol composing 2 functions. Maybe so, maybe not. Glue 2 functions together to make a new function. And in this case, it's gluing lenses together and traversals together. So you read, I generally read dot right to left. So find all the things where the digits are even. Traverse it, so go across all of them. Then go into the ARN, so this is going a bit backwards, into the aviator's logbook. Singular says, get the first one across that traversal. Once you've got that, over that, call the successor function, that's add 1. And that will return me a function from logbook to logbook. Okay, so what I'm trying to do here is squeeze in a lens. I do have a lens tutorial, by the way. It goes for about 8 hours. We sit down and write code. So I'm trying to squeeze that in right now. This is how we solve that problem with functional programming. It is a solved problem, thanks to Ed and many others. I don't know if he's in the room, probably not. But Ed Komet and many others contributed to solving this problem because we actually, about say 6 or 7 years ago, we come up against some barriers in the theory and we weren't able to make progress. And those were overcome by that recent work. So it's not so bad. Does everyone agree? Does anyone? It's not as bad. And I would have agreed with you 10 years ago. Especially for that 0 or 1 problem. That was quite a problem for us. Okay, so I'll show you a few others. These are examples of queries that I have been asked. So what are all the aircraft that you have flown? Okay, going into the aircraft. Folded means run across it. It's similar to traverse. Get all the entries out of the logbook. Give me a list of the aircraft. There we go. Find the first flight in the aircraft VVO. It looks like that. So what I'm trying to demonstrate here is the code is not exploding just because the query is getting more and more obtuse. Total hours, basically go in there, add them all up. This is real Haskell code using lenses and traversals. And, oh yeah, if Casa knocks on my door, I'm just going to call the compiler function. Here you go, have some HTML. Hasn't happened yet. But I actually have another function that says send it to the printer because I know which printer I'm going to send it to. And so it's over there. I'm going flying by. So basically my goal, this is my real goal, is I came up with the most obtuse thing that I could think of. And I wanted to say I can solve that problem with code. Now this is just the dumbest thing I could think of. And the reason, could you imagine doing this with Excel? Okay. And when I say can you imagine, I've seen what happens when you do this kind of stuff with Excel. This kind of thing, this is the kind of thing that we need to do on logbooks. And I'm only picking on logbooks at this time. I'll show you a few others in a minute. But these are the kinds of operations I need to do on logbooks. And it's done manually. I have seen it. And I get examined on it. Do you know how to count things with a pen and paper? And I call it flash computing, so just making a human do a computer's job. So if you go and talk to, like flight instructors, they will, well, at least they complain to me. It's like I spend 3 hours on the ground for every hour in the air or something. Well, those 3 hours are flash computing. Okay, so that's how I do my logbook. Every now and then I go onto the Aviation forum. I guarantee you that there's a question, hey, what's everyone using for logbooks? And I just write Haskell and see what happens. It's open source. It's quite interesting. You should try it. Okay, so I'll tell you about another topic, which is aeronautical data information and how it works in Australia. There's some. So basically, I'm going to pick on this a little bit more than I should, but that's because it's an area that I think is easy to understand. So that's all I really want to. I just want to talk about something that's easy to understand. So this regulation is about the publication of visual navigation charts. So visual navigation is what I do, is what I'm allowed to do. There's other kinds of navigation, such as using instruments. When you take off from Sydney and you fly through the clouds and so on, that's not visual navigation because all you can see is a cloud. So I'm only allowed to do visual navigation charts, and this regulation is all about how that works. Okay. So this one says if I ever go flying visually, which I do, I must carry aeronautical data by law. That's sufficient for that planned flight. And this is a chart called the visual terminal chart of Brisbane. It unfolds to 1 metre, that's about 1 metre, to half a metre. That's how big it unfolds to. Okay, I fly a Cessna. A Cessna's cockpit is not that big. Yeah, it's true. My Cessna does unfold to about 1 metre. Not a 206, no. Much smaller than a 206. And it's updated by Air Services about every 3 months, all right? So every 3 months I've got to go and buy a new one because someone built a dirt mound and now it's on the chart, a new chart. By the way, don't we have that problem solved, programmers? Yeah? You have some data and then you do an update to that data and now it's new data. Yeah. All right. So these charts are required by law, and I do not open that chart. That would be bad. I would do my visual navigation with no windscreen. So, I just don't. So there's training procedures to get around this problem. So I actually memorize the important bits. Every now and then you'll be flying along with an instructor, and they'll say something like, "What's the airspace restrictions here?" Or, I've got to find out my location and so on without looking at the chart. And the reason is because the jets are above me or something like that. You don't want me bumping into you when you come to visit me, right? So it's important. And I actually measure against risk, and I think most people do that. Some people get really good at it. I'm not good at it, I admit. It's hard. So there are times when I'm looking at my chart, Cessna's quite vibraty sometimes, a bit of turbulence, and I'm like, oh, what's going on here? And I have to then put the chart down and do visual flying again and then pick it back up. I don't know, other pilots in the room, maybe you have this problem too, but I struggle with it. So the point is, do they exist in electronic format? Well, yes. There's a problem, at least from my perspective. First of all, they exist in electronic format as long as you use the approved source. All right, that's fair. All right, you don't want someone publishing a chart on the internet and they forgot to put the mountain there. Whoops. All right, we must use an approved source. That makes sense. That's okay, we'll use approved charts. Aeronautical Information Service Provider charts. All right, that's the law under Regs 175. There's a problem. All right, so anyone who's done anything with geodetics or something will know that 2 lines of longitude are not parallel. Right? We all know that. So if the paper charts are the authoritative source, which they are, then we have to fly across JPEG files. All right, so that's really what we do if we're going to use electronic ones. All right, so I'm sure you're a programmer, you know the consequences of that. And they don't geo-rectify, okay, it's due to that problem, like in terms of projections and so on. They do not geo-rectify. And you might go, well, that's no big deal. It's only a little bit. 1 mile, whatever, it's okay. But let's talk a bit about accuracy. All right, so is accuracy important? So here's RAF Base Amberley. It's quite a large Air Force base. There's Greenbank Army Range. There's Archerfield Airport. And there's my house. Is it important? Here's the actual chart. There's Greenbank Army Base. There's Amberley. There's Archerfield. All right, and basically, see these R's here, R and R, that says restricted area. All right, so Amberley is restricted area 1 sometimes. You have to check. In fact, there's actually an incident of someone checking on the ground, taking off, and it changed while he was taking off. at Archfield. However, Greenbank is RA3, which is the highest level of restricted area. So basically, if I remember rightly, the information says if you call up an RA3 area and say, can I have clearance, the answer is definitely no. It's something like that. Okay, so, so if I'm here, I can't go there, and I may be able to go there. And I need to do a fair few procedures. But what if I screw up? So this is out of a document called the Aeronautical Information Package by Air Services. And this is called the interception procedure. All right? So my written exams usually have so I've sat quite a few of these, they usually have the interception procedure. It's things like, you know, if a fighter jet appears off to the left of your nose and waggles its wings, what do you do? Crap myself. And it's funny, I'd sat quite a few of these exams, and then I went to an air show just last year, and there was a stand there with the Air Force. There's a guy with his RAF uniform on. So how are you going? He said, yeah, okay, what's your job? He says, my job is to make sure pilots don't keep cursing on our airspace in Amberley. Oh, okay. I said, I hope I never do that. He's showing me this map. He's like, oh, here's the farmer from Alice Springs. He didn't even have a radio and so on. I said, look, I've got a question, right? If I screw up, are you going to send an F-18 up? And he said to me, we used to do that, but pilots tended to crash when we did that. We don't do that anymore. That was his answer. And I thought, I can understand that. I mean, if you're in cursing airspace, you're already lost, right? And suddenly there's an F-18. Birds are scary enough. All right. So we'll just use the non-certificated aeronautical charts. This does exist. You just get restrictions on your operations. There's certain things you cannot do anymore. But there's a problem. And I'm going to tell you about this aircraft incident. This is a New Zealand registered aircraft, or it was. And CFIT means controlled flight into terrain. So this aircraft hit terrain. It did not lose control in flight. So losing control, for example, is like it stopped flying, the wings stopped producing lift and fell out of the sky. This did not happen. It was controlled flight. So there's the primary factor in this incident, which was a condition called VFR and IMC. So VFR is where you're following visual navigation rules, visual flight rules, and IMC is when you've lost your visual reference. And it is a very dangerous condition. And in fact, there is one report on like a study. It wasn't a study, but a report on this condition. And the question was asked: what is your average time to death if you go VFR and IMC? CASA did this report. Does anyone know the answer?
179 seconds.
178 seconds. Yeah.
I was just being an optimist.
Yeah, you were. You live 1 second longer than I do. So it's about 3 minutes. Yeah. So basically, it's simply you're flying visually, and you're following all the visual navigation procedures, but you lose visual reference, and this is an emergency situation. So this aircraft had done that. In order for me to get my license, I had to simulate VFR and IMC and then execute a maneuver to exit IMC. I had to demonstrate to an examiner that I could do that. So if I do, I've never done it, but if I do find myself in IMC, I need to get out of it. This guy did not do that. All right, so he did not do that. He sustained IMC, this pilot. So this is a known problem where confidence takes over, being a bit more sensible about the flight condition. So it's worse if the aircraft is not equipped for instrument conditions and the pilot is untrained. All right, so I tend to fly aircraft that are equipped, but I am not trained for instrument conditions. So this aircraft was neither. Okay, so it's a VFR, but because it's restricted in its operations, it has lots of cool stuff on board. So my Cessna has mechanical gyrometers, and this one has really cool electronic displays with aeronautical charts. So this is an excerpt from the report, based on the avionics system. So here's monitors that were on board, and this is a picture from that incident. And I have a question about this, and certainly this report did as well, which is, here's the aircraft. There's a terrain height position ahead at 12 o'clock. What's the height of the terrain? Something 717. So, yeah. Yeah, I've heard many answers. So, there's a couple of problems here. The obvious one is you can't see that digit. One is that this is saying above ground 409 feet, and that's incorrect. The terrain data is incorrect on this in this avionics system. That number's a 3. And this aircraft is currently at 3,500 feet. So this is from the report. This is what the report believes the pilot has seen on the avionics display. So basically, yeah, so the report says it is likely that the pilot believed, first of all, was VFR and IMC, and then depended on the avionics to get through the instrument conditions. And the 3 was interpreted as a 1, which resulted in impact with terrain. Now, I don't know about you, like VFR and IMC, sure, that's irresponsible, it's illegal and very dangerous, but I don't know about you, I'm a programmer, I feel a little bit responsible for this stuff. That's not cool. All right, a little bit of me gets taken away. It's like, that's my job, to make sure that kind of stuff doesn't happen. Software works and so on, that's why I use functional programming. So, feel it. I feel it. And just to be clear, this is what really happens. This is a real VTC that I have marked for a visual navigation exercise. It has a scale of 1 to 250,000. I fold it. Before I go flying, I do the folds in the correct spot so that I don't have to do these ones. And I mark so basically Archfield Airport is just over here. And this is my track, this pencil line here. These little dots are 10 nautical mile markers. And you can see the airspace. So this CLL 3500. When you come and visit me, you're above 3,500. That's you in your Qantas jet, and I'm below you. So I can't go up there. And you can see it says C25, 2,500. There is actually 1,500. So I take off, I do 1,500. When I cross this line, I then can climb to 2,500, 3,500, and so on. The way I determine where I am is by looking out the window. All right, I go, there's my house. I know where I am. It's not quite like that, but something like that. Okay, and you can also see radio frequency boundaries. So if I do incurse into this airspace, they will call me up on this frequency here. I can't quite remember that. I think it's 129.0. I can't remember. It says something like that. So there's a radio frequency boundary. There's another one here, 121.2, and so on. So as I'm flying along, I need to change radio frequencies, so that if I do something wrong, they know where to call me. So if I'm a very irresponsible pilot, I will go up into the class Charlie airspace above this level here and be on the wrong frequency. It happens. But here's what I really do, is I take this chart here, which is called the World Aeronautical chart, which is at a 1 to 1 million scale. All right, so it's a lot more condensed. There's the same route again. And I transfer over the airspace restrictions and the radio frequencies boundaries from that chart. Now, don't we have a solution to that, programmers? I generally call these things lenses and zippers and so on. Viewing data within data is, like taking data and viewing parts of it, or 0 or 1 parts of it, and so on. I do this already using lenses and zippers, as I've just shown you. So, I don't know. One day, I've already told this story, so it's already on camera, and I'll tell it again. So I was flying along. I was actually, where was I? I was here, and I was heading that way, and I was at 3,500 feet, and I was I'd lost a little bit of where I was. Like, I knew I was around here somewhere, but and then immediately I established where I was, and then I realized I was here. I was about to go into that 2,500. Okay, and I've never done it. I've never actually gone into controlled airspace, and I've heard all the stories, and it's like, oh no, I'm about to become a story. And as soon as I realized where I was, I heard the tower they keyed the mic. I heard there's a sound that comes on your headset when they key the mic. It's like, oh no, it's about to happen. And I've started turning the air, so I basically did a U-turn, like kill the power and get around. And then I heard the mic get let go. That's happened. And yeah, a little bit of poo came out. So I crapped myself. It's like, oh, that was so close. And I nearly violated controlled airspace there. And then I descended down to 2,500, wiped the sweat off, chilled out a bit, and went home. So that's my story. I hope I'd never actually do that, but I do know that people do that. So I don't know. Maybe we programmers have better solutions to this problem. Okay, so I'm going to tell you about fixed-wing aircraft weight and balance real quickly. Okay, so how does an aeroplane even fly? It has a center of gravity, and it has a center of lift or center of pressure. So the lift is pushing upwards, and the center of gravity is if you balance the aircraft. There's also a downforce on the tailplane at the back there to stabilize it. This applies to every aeroplane, including that one. So that's just the general rules of how aeroplanes work. Center of gravity, center of lift, and a downforce on the tailplane. So weight is making sure we get off the runway. That's so making sure we don't go overweight. Yeah. So making sure we get off the runway. There's trees at the end of the runway. You're sitting there. You've had a few cheeseburgers or something. You're weighing a bit, and there's trees at the end. And I don't want to slam you into the trees. We make sure we're not overweight. And balance is making sure that their center of gravity is positioned so that we can control the aeroplane. So if the aeroplane's too far, the CG's too far aft, and we pitch up, I have the ability to pitch it down. If it's too far aft, I won't. It'll cause problems, and vice versa if it's nose heavy as well. So we're making sure we're within limits. So I'll tell you how to do that, or at least how I have to do that. So in my aeroplane, I have front and rear seats, I have 2 baggage compartments, fuel and oil, and the aircraft itself. All these things have what's called a weight, so a weight in pounds. Pounds. How much do you weigh? Something kilograms, right? And it also has an arm, so the distance from the center of gravity. Right, the fuel tanks are some distance from the center of gravity, and compared to like the baggage compartment, for example. So basically, I multiply each of these weights by the arm for each of these. I sum them up, and then I put them on this graph. So here's the weight. The sum of the products of those arms is called the moment. And if that point falls within there, we're going flying. And if it does not, we're not. Okay, so that's how you do a basic weight and balance. This has happened to me. So when I do a weight and balance, I generally do it the day before when I'm chilling at home and I've got no pressure. I'll do all the calculations, I'll double check them, I'll triple check them, I'll make sure it's a safe flight, okay, without any stress or pressure. But this happens a lot. It's happened to me, and this is what it's like, screw this, I'm going to fix this problem. We've changed your aeroplane. Oh no, I have to start again. Or Jessica wants to sit in the front. Well, Jessica weighs a different weight to the other person who was sitting in the front. All right, so if we're near limits, this is going to cause problems. Mostly what happens in practice is some people go, oh, Jessica doesn't weigh that much less, she'll be right. And I'm not cool with that. So to me, I felt pressured. This actually happened to me once. I felt pressured. I have to do these calculations again. Error prone. We're taking off in 10 minutes. I can do it in 5 minutes, but the chance that I get it wrong goes up. All right. So I felt pressure, and it annoyed me a lot. And I said, "Come on, this is just a bit of arithmetic." So basically, I did it in Haskell when I got home. We did go flying, but then I went home and I wrote some Haskell. Jessica's a function argument. All right. Jessica comes in as a function argument, and out comes my flight envelope. I think that's cool. All right. So if we want to swap seats, I simply change the code. Simple as that. And different aircraft, function arguments, and so on. There's a package in Haskell called diagrams. Diagrams, you basically write a diagram using Haskell, and then you compile it to PDF and so on. All right, so I'll show you an example output. This is an example output from the diagrams package. I think just due to the contrast, you can't see that there's a grid lines there, but there actually are on this rectangle here. This green line here is the fuel burn line. All right, so I have to make sure that regardless of how much fuel we burn, we are still within limits, and so on. So for this flight, we were within limits regardless of the amount of fuel on board. So I keep them revision controlled. Most people scribble them on paper and then throw them out when they get back to the airport. So I know my weight and balance from a flight a year ago, and it's an open source library. So basically what I'm saying is if you fly a Cessna, the arithmetic's done. And I have types, by the way, so I can check that it actually works. This is cool. Change the type of the aircraft. Yes, I have this problem right now, yes. Yeah, it'd be good if the type reflected the actual different values themselves, yeah. Anyway, so this is a screenshot of the source. There's me, there's Jessica. 55 kilograms, she says to me, right? Something kilograms. And all of that gets normalized. Arms are given in inches, of course. There's actually a unit of measurement called Cessna pounds, which is a rounding. So it's something like how much avgas, how many pounds in a gallon of avgas or something like that. The real answer is 6 point something, 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 and Cessna said, 6. All right, I'll call those Cessna pounds, and so on. So real quickly, I'll show you something called ADSB. I'll tell you about ADSB. ADSB is an electronic system on board, certainly all instrument aircraft, all the ones taking off from Sydney right now, that broadcast the position and track of the aircraft. Altitude, rate of climb and descent, and so on. And we can receive these on the 1090 megahertz frequency. And here's some hardware that I can do it with. And immediately I thought, when I learned about this, is that can I spoof an aeroplane? Can I stand at the end of the runway and just pretend that there's an aeroplane there with some software? The answer is yes. It's been demonstrated. It's basically, the reason it doesn't occur is dependent on just don't be an idiot, right? There's no real security. So this is some hardware. This hardware is currently sitting up the back of the room. It's got a Haskell sticker on it. We know it's going to work. It's got a gyrometer on board, or an accelerometer, electronic gyrometer. That's the web interface to it. There's some air traffic. So you know Java's got like JavaDoc and so on. You can view an API. Haskell has a similar thing. This is an example, and this is the data type for reading traffic. So air traffic off. So I'm going to interact with that device using Haskell, and I'm going to get values of this type coming back. So it's got latitude, longitude, and all that sort of business. So this is also the situation on board that device. So its current latitude and longitude, its roll, pitch, and yaw. So its movements on the accelerometer. One of my goals, so this was more of a fun thing to do, but my goal was simply this. Can I fly around Brisbane and automatically SSH back to my server at home and send all of my flight telemetry as I'm flying along? Can I pitch the aeroplane up? And Amanda's like looking at this data going, what am I paying all this money for? And the answer is, I got to pitch the aeroplane up. That's really all there was to this goal. And can I do it cheaply, right? So for those of you who are familiar with aviation, you will know that everything costs 3 zeros on the end of what you would normally think otherwise. All right, so can I do this cheaply? Yeah, everything is just 3 zeros. You want to buy a Bolt or a Cessna Bolt? 3 zeros. Okay, so I'm going to write some code. I'll show you some code first. Let's not look at Java code anymore. All right. I'll just try to quickly walk you through this Haskell code here. So this function here, this caret dot, is a lens function, and it's saying view the pressure altitude through the entire data structure. And it assigns it to this value PA. And it does that for all of these values, and it constructs a string. And one of the neat things about this code is we look at the type, and that type there returns a string. Now, if you were using, say, Java or something like that, and you returned a string, we ask the following question: does that function delete the database? The answer in Java is, I don't know. Maybe. We better go and check the Git history, see if someone snuck it in there. Did it update the configuration file? All of these things. Now, in Haskell, I look at this type, and the answer is no. It did not. It cannot. It won't compile. Right, so this is one of the immediate consequences of functional programming is this type returns a string. It does nothing else. It cannot do anything else. All right, so it constructs the string. And then this function here says put it in a loop doing I/O. So the answer to the question now is it's doing I/O. All right, so it's a separation of these two concerns. One is building up the string, and the other one is doing the I/O. I'm going to call this function. Demo1 just says go through a loop, pausing every, I think that's 0.4 seconds. All right, so this function here is going to get all the telemetry off the device itself. All right. There it is. All right, so that's coming off the device, and it's telling me the pitch, roll, heading, that's the yaw, the latitude, longitude of the back of the room is that, and so on. And so it's also SSHing to my house and sending it all that. I thought that was cool. I did it for $200. More interestingly, this program here does a similar thing, but it is not reading from the gyrometer or the device. It's reading off the 1090 megahertz aerials, and it's receiving traffic from nearby aircraft. So there's aerials up there. So I don't know. We're pretty close to Sydney Airport. Let's see if we can get some aeroplanes. Whoops. Let's try that again. All right, there we are. We are receiving aircraft. So I can see a couple of flights there. ADS-B is a ping. I think it's once a second. So there's a Qantas flight 515 going past. Let's kill it and have a look. It's oh yeah, the whole zero thing is a problem. You know, we brag about, you know, we don't have null and all this sort of business, us functional programmers, and then we show you this. Sorry, working on it. But ignoring that, if we look at Qantas flight 515, that's the signal strength. It's latitude and longitude, wherever that is. It's currently at 6,000, or it was at 6,700 feet at 283 knots, and it's descending at that speed. So that's probably coming into land at Sydney Airport and so on. So, you know, I did that experiment just thinking, you know, could I write some software that, I don't know, maybe I don't bump into other aeroplanes automatically, and, you know, I get warnings. You know, unlike when I nearly violated that controlled airspace, it was, you know, I basically saw a town. It's like, I know which town that is. That means I'm here. Oh, crap. So can we programmers help? I could rant to you all day long about things that I've seen in aviation where it's like half an hour's job, and it's saved, say, a flight instructor from doing something all day long. There's so many instances of this. These are just the ones I found interesting and I thought you might find interesting. Thanks for listening. And I don't know if I've got time for questions. Do I have time for questions? Oh, yeah, thanks.